Hello everyone, welcome to week 8 of Codivate Python class. We have a very interesting topic for today. It is functions. We're going to go over the syntax in Python and how to use them. So what is a function? Let's go over some of the basics. We've been exposed to functions before when we worked with strings and lists. There is the len function, which returns the number of items in a list or characters in a string. We've also seen the max and min functions for lists. So why would we use functions? Well, the reason is because they are organized and reusable algorithms that can perform similar tasks with different inputs. In our example functions that I just mentioned, we can change the input for the string and the len function will still work. Usually a function takes an input. We can think of functions using a real-world example. Let's say we have a machine in a factory. It takes in some materials, manipulates them, and returns a finished product. The machine is doing a function. Functions in programming are very similar. They take an input, perform some operations with it, and return an output. Now we will go over how to write functions in Python. Let's take a look at an example function to analyze the syntax. We start each function with def, which is the keyword to indicate we want to define a function. The def comes from the word define. We are defining a function here. Then we have the function name. In this case, we called it greet. So our function is named greet. After we have our function name, we have parentheses to contain the parameters or the inputs. In this case, we have a parameter called name. It is possible that we have no parameters or more than one parameters, but we will get to that later. And even if we had no parameters, we would still need the parentheses because it is part of the function syntax. If we had more than one parameter, we would need a comma in between each of the parameters, and they would still be inside parentheses. Now we go to what's actually inside of the function. Whatever is inside the function will be inside its indentation here, similar to what we had with loops and conditionals. So what's going on inside this function? It takes in a parameter called name, and it prints hello concatenated to the name. If we wanted to call the function, all we need to do is the function name on a new line in Python, put our parentheses, and then inside the parentheses, put our arguments. And these arguments are what we actually put in the place for the parameters. So when Python sees this, this is what is happening. It sees that we want to use the greet function, so it sees where it is defined. It sees that it takes one parameter called name. So in this case, we entered our argument for the parameter to be Bob, the string Bob. So what it will do is it will think of this name variable as Bob. And when it prints it, it will print hello Bob. So we'll do the same thing for greet, and we have this time the parameter, our argument, is the string John. So our output will have two lines. This first line will give us hello Bob, and the second line will give us hello John. Just a quick summary of the main parts. The variable that we use to define inside our function is called the parameter. The value that we actually enter is called the argument. So here the parameter is name and the arguments are Bob and John. Alright, so in the previous function, what we did was printing something. And there's another thing we can do, and this is called returning. We can return a value from a function. In this case here, we return a string based on the given input. Return is usually the last line of a function, or it ends the function wherever it is. If a function returns a value, we can print a call to the function to see what is returned. Or we can also assign the result of the function to a variable. So when it comes to an example of a function that returns something, once again, we can think of our len function. Given a string input, the len function returns an int, which would be the number of characters in the string. As we would do with len functions, we can print the function call onto the console. In our example here, since we are returning the string Bob, what this does, greet Bob, it will be replaced with what it returns, which is hello Bob. So you can think of this print statement as printing hello Bob. So the main takeaway from this slide is that if we return something within a function, it returns a value instead of just doing some action like printing. It will actually give us a value. And we can print that value, we can assign it to a variable, we can do anything we want with that value. Okay, so this is an interesting thing if we combine some of the things we learned. If we have a function that does not return anything, and we try to print the call to the function, this is what would happen. The fact that we call the function greet Bob would print hello Bob. Greet Bob, Bob gets assigned to this name variable, and we print hello plus the name variable which has a value of Bob. So this would print hello Bob. But if you want to print a call to the function, we print whatever is returned by this. Well, there's nothing returned by this, so it would basically print none, because nothing is returned. The way that Python thinks of nothing is none. Let's get some practice with evaluating functions. If we have this function, what will be printed by the following function calls here? You can pause the video, give it a try, and play when you are ready. Alright, I'm assuming you had a go at it. For the first one, our A value is 4, and our B value is 5. Let's take a look at the evaluation. We have to think of this as returning the expression 2 double asterisk 4 %, 5. So what do these operators mean? Let's go back to an earlier lesson. These double asterisk means raised to the power of. So this would basically be 2 raised to the power of 4, which is just 2 multiplied by itself 4 times. And based on order of operations, since this is an exponent, we do it before modulus, which involves division. Modulus, just as a reminder, is the result of the remainder in a division problem. First thing we do here, we do 2 raised to the 4th power, which is 2 times 2 times 2 times 2, which is just 16. We take that result and we do that result modulus b, which has a value of 5, so we do 16 modulus 5. Well, 16 divided by 5 is 3, and then the remainder in that case would be 1. And since the remainder is 1, that is our final output if we were to print this out. Alright, for the second one, we have a similar process. We do 2 raised to the 6th power, which happens to be 64, and we do modulus 2. Since this is an even number, we know that it's divisible by 2, which means that that number, modulus 2, will have a result of 0. Another way we can evaluate this in an easier way is through some basic math. If we multiply 2 by itself a few times, which is what we're doing when we're doing 2 raised to the 6th power, it will still be divisible by 2, confirming that when we do that result, 2 raised to the 6th, modulus 2, the result has to be 0. Let's do a practice problem to test our function writing skills. We want to simulate dice rolls. Write a function that takes in the parameter n for the number of dice rolls. Return a list of the results for each roll. Let's say our function is called diceSim, and we enter the parameter 5. Enter the argument 5 for the parameter n. And this will output a list of 5 dice rolls. We have 3, 1, 5, 1, 6. If we did diceSim with an argument of 10, it will give us a list of 10 dice rolls. So, as we know, a dice roll is just any random integer from 1 to 6. So some things to remember for this are to import the random module called the randint method, and since we're adding each of the rolls to our list, we have to use list.append. So now would be a good time to pause the video, give this question a go, and play when you're ready to review it. Alright, I'm assuming you had a go at it. Let's go over the solution. First, we have to import the random module because we are simulating dice rolls, which is a random event. That's what we have in our first line, import random. Now we have to go to our function header. And in this case, we just called it diceSim. Let's just review the syntax really quickly. We have the def for define, the diceSim for the name of the function. We have a parentheses, and inside we have a parameter, which was n, the number of dice rolls. We end off our function with a colon, which will create the indent inside and allow us to write our entire function. Inside the function body, we are going to first create an empty list called row list. As we do the rows, we will add our results to this row list. Now we're going to use a for loop to repeat this process of the row n times for I in range n. So as you recall, this will repeat an event n times through this for loop. It will just do this, whatever is inside here, over and over n times. And what we're doing in here is getting a random number between 1 to 6 and adding that result to our row list. How are we doing this? We are first creating a variable called row. And to that we are assigning random.randint 1, 6. So this just simulates a dice roll. We're getting a random integer between 1 and 6. That gets assigned to row. That would be the result of our row. And we add that to our row list using the append method for lists. We repeat this inside a for loop n times. And once we're done, we return our row list. That is what it told us to do before. Return a list of the results for each row. So we return it using the return keyword. So once we're done, it's always a good idea to test our function. So we have this line at the bottom, print diceSim, and then in parentheses 10. This should give us a list of 10 dice rolls. When we run this code segment, you can see that it correctly gives us a list of 10 numbers that are between 1 and 6 to simulate dice rolls. Alright, let's move on to another topic for functions. So in Python, when specifying parameters for a function, we can also have a default parameter in case the user just doesn't enter the parameter or an argument. We assign the default value like we would with a variable inside our function header, inside the parentheses. Here our parameter is lang, and it has a default value of English. So unless the user puts something inside the speak function, the default will be lang. So what this function will do is it will simply print. Remember, it's not returning anything here, so we can use it directly. It's just printing I speak concatenated with whatever language is inputted in the parentheses. And if nothing is inputted in the parentheses, it will just say English. I speak English. So let's think about how each of these function calls work. The first one, speak French. So in this case, lang is being assigned French because we actually entered an argument here. So we'll print I speak the value of lang. The value of lang, we made French here. So we'll print I speak French. The second function call, we don't put anything here. And in the case we don't put anything here, we are supposed to get English. Our lang variable gets the value English. And it will print I speak, value of the lang variable, which was English, so I speak English. The last case, which is similar to our first case, speak Spanish. Lang is being assigned the value of Spanish, and we print I speak Spanish. So let's say we have a lot of code we wrote, and at the end we know that our next step is to write a function header. But before we actually write that function, the entire code inside the function, we want to test our other code, so just to make sure it works correctly. If you want to do something like this, if this is what we actually do, like let's say we have a bunch of code and then we started writing this function but we didn't finish it, and we want to test our code above. This would cause an error because it's expecting something to be inside of here. We get this unexpected end of file, that's what EOF means, end of file, while parsing, and parsing is just, you can think of it as the compiler going through all of the code we wrote. It was parsing our code. So this is the way to fix it. All we have to do is inside our function, inside the indentation, just type this word, pass. You could think of it as telling the compiler to just pass over this part and assume that the syntax is correct. In this case, even if we don't do anything, this will still work without causing any error. So, there's a case we would use this. Like I said, if we had a lot of code and we wanted to start writing a function, we knew the header, but we didn't know that inside part yet, like the body here, but we still want to delete the function, we have to use this keyword, pass, to prevent any syntax error. Alright, this is another important topic. It is scope. It's about variables inside and outside of functions. In our case, if we have a variable inside a function, it is only present inside the scope of the function, which means it only exists inside the function. This means that we can't access a variable created inside a function outside a function, like we're doing here, like we're trying to do here. Here, our x variable is only defined inside this function. It has a value of 5. But if we try to access this variable x outside our function, it doesn't exist. If we defined it right here, for example, x equals 5, we had a line just before this, then it would print 5. But in this case, x is not defined just in the regular code. It is only defined inside the function, so we cannot access the variable like this. Let's do a practice problem. So this is a function writing problem. Our goal is to write a function that takes a list of numbers as a parameter and returns the range of the list, which is the maximum value in the list minus the minimum value in the list. The key thing to notice is that we want to return the range of the list, not just print it. And a challenge, if you want to practice another concept that we learned, is to use try and except to make sure that the list can only contain numbers. You may be thinking, well, recently we saw how to use max and min on a list with strings. That worked. Why do we need to make sure it's numbers? Well, in the context of range, usually we're talking about a list of numbers. We don't really want the range of a list of strings. That doesn't really make sense. So just for practicality, it's a good idea to make sure that everything inside the list that we're taking the range of is a number or a float. So you can pause the video now and try this problem. You could do it with or without the challenge, up to you. And resume when you are ready. Alright, let's go over the solution now. So our first step is to do our function header. We used the def keyword, range to specify the name of the function, And our parameter is the num list, which will be our list of numbers. So we can have a lot of parameters or just one parameter, and we can also have parameters that have multiple things inside them, like a list. We would just have to treat them as a list variable. Our first step is to make sure that we can actually cast every single item inside the list as a number, because that's what our challenge exercise did. So we try, and inside our try block, we try something that might cause an error. We loop through each num in the num list and try to cast it to a float. If it can be cast as a float and we make it this far, that means we would have a list of all numbers. And if we do, since we made it past these two lines in our try block, we would return the maximum number in our list using the max function and subtract the minimum number in our list using our min function. So max, and in parentheses num list, because that's the list we want the maximum value of, and the same thing for min. And our except block will take over in the case that when trying to cast each one of these items in the list to a float, we get some error. This would happen if we had a string, because we can't cast a string to a float. That just doesn't work. So it will return a string to us, which will say, list can only contain numbers. So it's always a good idea to test our code. We are going to make a list of nums here. Just by looking at this list, we know that the range should be 11 because our largest number is 12, smallest number is 1, 12 minus 1 is 11. We are making a variable here called range of list, and to that we assign the function call on this list. We print the range of the list, and our output is, as we expected it to be, 11. Now we also want to make sure it works for the case with the except. So we create an invalid list and assign it some numbers and also the string hi. If we try to print the range of this invalid list, we get the correct output, list can only contain numbers. In this case, this last case, with the invalid list, when we do our print of the range function, what happens is that it returns list can only contain numbers, so that is what we print. One interesting thing you'll notice is that the range function already exists in Python, which is what we used to make our for loops before. So if we define an already existing function and we want to use it later on, it will only take the definition that we gave it. It's called overloading functions, but that's not a major topic for today. It's just an interesting thing to know. So if we wanted to do for I in range, and we have this here, it wouldn't work anymore. Alright, let's do another practice problem. This one is called sum digits. Our project is to write a function that returns the sum of the digits in an inputted integer. For example, if we had a number 205, the sum of its digits is 2 plus 0 plus 5, which is 2 plus 5, which is just 7. Alright, now would be a good time to pause the video, and now we will go over the solution. There are a couple solutions for this one. The first one involves converting the integer to a string, so we can traverse each character inside the number, but it's kind of being seen as a string. The first thing we have to do is obviously define our function. We use the def keyword for define, name the function sum underscore digits, and in parentheses we're going to be taking the sum of the digits of a number, so we're just going to call our input num. Once again, we have to remember our colon at the end of a function definition line. Now we can begin our code inside the function. First step is to create a variable called sum and assign it 0. We're going to be going through each digit in the number and changing sum based on whatever that digit is. So what we want to do, since we are traversing it and we can't just traverse an integer, we can only traverse iterables. So we're going to make our num into an iterable. we're going to make it into a string. So we cast our num to a string version of itself. Now our num that was entered, which was an integer, it's now being seen as a string, with each of its digits as a character. After we have made it into a string, we traverse it using a for loop. So for each digit in the string num, what we're going to be doing is incrementing sum by the current digit cast as an int. Remember, if we are just adding the digit regularly without int casting, it will just concatenate it since it is a string. But since we want to actually get the sum of the digits as a number, we have to cast it as an int before we add it to the sum. Once we're done with all of this, we just return the sum at the end. Another way to do this way is a little bit more practical for other languages because it doesn't involve casting to a string and it's more mathematical. We still have to have the same function header and initialize the sum to have a value of 0. This time we use a while loop to traverse the entire number. While our number is greater than 0, it's an interesting condition, but you'll see why in a couple minutes. So the first thing we are doing is we're incrementing sum by the last digit in the number. The last digit in the number is just whatever the number is modulus 10. So why would this work? Let's say we have a very large number, I don't know, 2,587. If you do modulus 10, since the 2,580 part of the number is divisible by 10, all of that goes away. The remainder is 7, which was the ones digit. You could try this for a lot of numbers and it will still give us the same result, because anything in the tens place and beyond will be divisible by 10. So this leaves us with only what is in the ones digit, which gives us one singular digit that we can add to our sum. So once we are done with that last digit, we want to get rid of it. And in order to get rid of it, we divide the number using integer division by 10. So if we do normal division by 10, you can think of it as shifting the decimal point one place to the left. But we would still have some number after the decimal. And if you want to get rid of that number after the decimal, all we need to do is use integer division, which chops off the remainder and ignores it. So now this will take away the last digit. And if we had our example of 2,587, if we do integer division by 10, that would leave us with 258. Then we come back to the top. Now 258, we add its last digit, chop off its last digit, and then keep repeating this process until we are left with nothing. Because as we keep chopping off the last digit, eventually we'll have 0. Once we're done with this process, we return the sum, and it will give us the same result as the other function. This is another interesting practice problem for the day. It's the last one before we get to our exercises. So let's go over it. A list is considered cool if it has an even number of even numbers and an odd number of odd numbers. Write a function that takes in a list of numbers as a parameter and returns true if the list is cool and false if it is not. Here we have an example of a list that is cool and an example of a list that is not cool. The first list has 1, 2, 3, 4 even numbers and 1, 2, 3 odd numbers. Since 4 is even, that means we have an even number of even numbers. And since 3 is odd, we have an odd number of odd numbers, and this list is cool. In the second list, we have an 1, 2, 3 odd numbers and 1, 2, 3 even numbers. We have an odd number of odd numbers, but we don't have an even number of even numbers, making this list not cool. Now would be a good time to pause the video and give this one a go. Alright, let's go over the solution. Our first step is to define the function. We're going to call it isCoolList, and it will take in the parameter a list of numbers that we called numList. Inside, we're going to be creating two variables and initializing them to 0, even count and odd count, because we want to go through the list and see how many even numbers are there, how many odd numbers are there, and then let the user know if there's an even number of even numbers and an odd number of odd numbers. So we are going to loop through our list, and we are going to increment even count by 1 every time we see an even number, and increment odd count by 1 every time we see an odd number. You may be seeing this syntax for the first time, but it's okay. What we're basically doing here is doing what we usually don't do on 2 lines with making 2 variables on 1 line. So even count is being assigned 0, and odd count is also being assigned 0, because before we start going through the list, we have 0 of even numbers and 0 of odd numbers. Now, our next line is the actual loop. So for each num in the num list, this is just a for each loop. We're going to be looking at each number in the num list. If num modulus 2 equals 0, what does this mean? As we've seen before, it means if the number is even, because it's divisible by 2, since the result, if we divide it by 2, has a remainder of 0. So if the number is even, then we increment even count by 1, because we just saw an even number. Otherwise, since a number can only be either even or odd, we have to increment odd count by 1. If you want, you could do an elif condition with num mod 2 equal 1, but that's not the most efficient way to do it. We could just use an else, since we only have 2 cases. We repeat this process for each number in the num list using our for loop. And at the end, we return this boolean here. So you may be wondering, how can we just do this? Won't this cause an error? Don't we use this with if statements since it's a boolean? Well, as we learned, I think back in week 1, or in our lesson with if statements, booleans can also be stored as variables and can be seen as values. Remember, booleans have 2 possible values, true or false. So this even count, this entire boolean condition will either evaluate the true or false. That's what we want to return, true or false. We're not returning the string true or false, but rather the boolean true or false. And since we're using a condition here, that will give us the result of a boolean. So what is this condition doing? We know modulus 2 equals 0 means is it even, and modulus 2 equal 1 means is it odd. So what it's checking here is even count even, and is odd count odd. If this entire thing is true, we will return true, because that's what it evaluates to. Otherwise, if this entire thing is false, since it evaluates to false, we return false, which lines up with whether or not the list is cool. That basically wraps up our cool list solution. It's always a good idea to test our code, and when we run the function on the example cool list, we get true, it is a cool list, and when we run the example function on an example not cool list and print the result, our output is correctly identified as false. These are the exercises for the day. Our first exercise is to write a function, count digits, that takes in 2 parameters, a num and a digit, and returns the number of occurrences of digit in num. For example, if we have the count digits function, and we had 2 numbers, 1, 2, 2, 1, 2, as the num, and the digit as 2, we would return 3. And the reason is because there's 3 2's in this number here. Our second exercise is to write a program that prints the numbers from 1 to 100. But for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz instead of the number. For numbers which are multiples of both 3 and 5, print fizz buzz. This is a common question asked in programming job interviews, and we will see if we can tackle it using some of the tools in our Python toolkit today. Alright, now would be a good time to pause the video, and we will review the solution when you are ready. There are a couple ways to approach exercise 1. We'll go over 2 of the correct examples. This first one is very simple and takes only one line of code inside the function. We know that we can use the count method for strings to see how many times a character appears in a string. And that is very similar to our goal of counting the number of a certain digit in a number. In order to make it work for integers, we can just cast both the num and the digits to strings, so we can use the method. So here what we're doing is taking the num, casting it to a string, and we're counting how many times in that num the digit cast as a string appears, and we were just returning that result. This other way is more applicable to other languages and doesn't involve typecasting. Usually when we are looking at things with numbers and we want to iterate through numbers, the approach that works well in Python is casting through strings, but the approach that works better for all languages is a methodical looping type of way. We have the same parameters as before, num and digit, but inside our function we have a completely different method here. We start off by having a digit count and assigning it to 0. Every time we see the target digit inside the number, we're going to be incrementing it by 1. So how do we loop through everything inside a number? Well, we saw this earlier in our SUMDigits method. Now we just have to apply it to our COUNTDigits method. While the num is greater than 0, we take the last digit and assign it num modulus 10. Once again, if you're not sure why this works, it's because as soon as we divide a number by 10, the remainder will just always be whatever is in the ones place. And that's the last digit in the number. If the last digit is equal to our target digit, then we increment the digit count by 1, because we just found one of the digits. After that, we chop off the last digit so we can slowly make our way through the entire number, and we do this using integer division. We repeat this process while num is greater than 0. And once we're done, we return the digit count. Each time the last digit will be moving to the left one place, so we will gradually make our way through the entire number. Always a good idea to test our code. Let's test the example that they provided us with, and our result is 3. Since there are 3 2's in this number 1 2 2 1 2. Now let's go over the solution for exercise 2. As I mentioned, this is an interesting interview question for programming jobs. It may seem daunting, but as I mentioned, we know the syntax to actually solve this problem. The first step in solving this problem is to use a for loop. And we are looping from the numbers from 1 to 100. Because remember, since range starts at this one and ends at whatever the last one is minus 1, we have to set this to 101 since we want to go from 1 to 100 inclusive. This way is the first way we're going to go about doing it. We're going to create an output string and just make it an empty output. If it is divisible by 3, that's what this condition is checking. If the remainder when I divide it by 3 is 0. If it's divisible by 3, our output will be added to it, fizz. Fizz will be added to our output. If our number is divisible by 5, then buzz will be added to our output. So this will take care of all the cases in which it's divisible by either 3, 5, or 3 and 5. If it's divisible by 3, our output will be fizz. If it's divisible by 5, our output will be buzz. If it's divisible by both, our output will have fizz added to it and buzz added to it, which will be fizz buzz. Remember, if we add strings to each other, they just get added one after the other. But this still doesn't take care of the case in which we have a number that's not divisible by 3 nor 5. In that case, we have to check the length of our output string. If the length of our output string is 0, that means fizz wasn't added and buzz wasn't added. In that case, we know that it's not divisible by either, and we just print the number that we saw. The number that we saw is our I, which is just taking the value of each number from 1 to 100. So we print whatever it is like it appears. Otherwise, if it has a length of an output that is not 0, which means it's not an empty string, it means it has either fizz buzz or fizz buzz. In that case, we would print our output. Our next solution that we can use for this one is without using this output string. Instead, we start off with the same for loop as before, which is for I in range 1 to 101, because we are looping through the same set of numbers. Inside the loop, we are checking if the current number is a multiple of both 3 and 5. If that is the case, print fizzbuzz. Elif, if the number is a multiple of 3, then we would print just fizz. Else if the number is just a multiple of 5, then we would print buzz, else we would just print the number as it appears. So it's very important that we have our conditions in this order, especially this statement comes first for this code to work. It's always a good idea to test our code. Obviously, I'm not going to be showing all the numbers from 1 to 100, but we can take a look at just a few of them. We know that 15 is a multiple of both 3 and 5, so it should print fizzbuzz. See 13, 14, and in place of 15 we have fizzbuzz. 16, 17, and since 18 is a multiple of 3, we print fizz. If we kept going and had something like 20, then we would print just buzz because it's not a multiple of 3, but it is a multiple of 5. This is a very interesting problem. I hope you enjoyed it. If you have any questions about this problem or anything at all in this lesson, feel free to reach out to our tutors on Discord. If you have any other questions, feel free to reach out. Thank you and stay tuned for next week.